So in this lecture we will discuss Fourier sine and cosine transform. So first we define what is Fourier cosine transform. Fourier cosine transform. So Fourier cosine transform is if f of x be an absolutely integrable function and is piecewise continuous, then Fourier cosine transform f of x is, so yeah, I define what is Fourier cosine transform. We will denote it by fc of omega or fc of f of x. That means fc of omega or fc of f of x. That is omega we denote by f of x. This is equal to root 2 by pi integral 0 to infinity f of x cos omega x dx. F of x cos omega x dx. Please note this formula. Cos omega x dx. Now its inverse Fourier cosine transform is so now its inverse Fourier cosine transform is denoted by f of x is equal to, we want to get f of x, this is root 2 by pi integral 0 to infinity fc of omega cos omega x d omega. So this is inverse Fourier cosine transform. So this is the formula. That means we are from time domain we are converting it into frequency domain. So these Fourier transforms are mainly used for the analysis of frequency of signals. Okay, and also which they are used to find solve ODE, PDE, etc. Mathematics. Now next I will define, similarly I can define Fourier sine transform. Fourier sine transform. Okay, Fourier sine transform. So for Fourier sine transform, we will denote it by fs of omega or fs of f of x. This is equal to root 2 by pi, same formula, integral 0 to infinity f of x. Instead of cos we will use sine omega x dx. This is Fourier sine transform, and its inverse Fourier sine transform is this. Inverse Fourier sine transform is f of x is equal to root 2 by pi integral 0 to infinity fs of omega sine omega x d omega. So there is only difference from on transform we will integrate with respect to x, and for inverse transform we will integrate with respect to omega. Okay. Now we will do problems. So these are the formulas you have to study. Okay. Now first problem, find Fourier uh, cosine transform of the function f of x is equal to 1 if 0 less than x less than 1, and minus 1 if 1 less than x less than 2, and 0 if x greater than 2. So please please go through what are the formula. So what is Fourier cosine formula? So just by heart this, fc of omega is root 2 by pi integral 0 to infinity f of x cos omega x dx. So this is Fourier cosine formula. Okay, tell me now. We will do the problem. So we have to find the Fourier transform of cosine transform of this function. So for that, so first we will write the formula. The Fourier cosine transform of f of x is, tell me what is the formula. We will denote it by fc of omega. Tell me what is the formula. Square root of 2 by pi integral 0 to infinity f of x cos omega x dx. So please by heart this right now. Fc of omega is equal to. Now tell me how to integrate this. So this is equal to root 2 by pi. So here 1 is when 0 less than x less than 1, the f of x value is 1. So we will split the integral. Tell me what is the limit integral 0 to 1. We have f of x is 1. 1 into cos omega x dx plus, now for 1 to 2 it's minus 1. Minus 1, sorry, 1 to 2 minus 1 into cos omega x dx plus, now 0 x2 for x greater than, that means 2 to infinity it's 0. So integral is 0, therefore all integral value is 0. So this is equal to root 2 by pi. What is integral of cos omega x? Tell me. Cos omega x integral is, say, omega x divided by omega plus, okay, this is 0 to 1 plus minus, take outside, cos omega x integral is sin omega x divided by omega 1 to 2. So if I put the limit, when I put the upper limit here, we'll get sin omega divided by omega minus I will put lower limit, then sine 0, 0, minus of sine omega upper limit 2. So sine 2 omega divided by omega minus sine omega by omega. Now here there is sine omega by omega, and here also minus minus. So this is root 2 by pi sine omega by omega minus minus plus. So you will get 2 into sine omega divided by omega. That means this plus this minus sine 2 omega by omega. So this is Fourier cosine transform of the function. So you have to remember the formula, then you can easily find Fourier transform. Next question. Fourier.
സർ
പറഞ്ഞോ.
സർ അത് ഫുള്ളായി കാണാൻ പറ്റിയില്ല. സാറിന് എന്തോ നെറ്റ്വർക്ക്
Is it visible? Visible ആണോ? കാണാൻ പറ്റുന്നുണ്ടോ? Is it visible now?
Yes, sir.
Okay. Okay. Now,
Yes, sir. Sir, also in between your voice is breaking.
I think there is some network issues. Okay, no problem. I will record this session and I will. So, next problem. Okay. So second problem. Find Fourier sine transform of sine transform of the function f of x is equal to sin x when 0 less than x less than or equal to a, and 0 when x greater than a. So here we have to find the Fourier sine transform. Okay. So now solution. Okay, am I audible now?
Yes, sir.
So the Fourier sine transform is sine transform. So first you have to write the formula f of f s of omega is equal to root 2 by pi integral 0 to infinity f of x sin omega x dx. Now, okay, so it implies fs of omega. Just we apply the function. So here f of x is sin x when x is in between 0 and a. So I can write 0 to a sin x sin omega x dx plus, and when a to infinity its value is 0, right? So this integral becomes 0. From 0 to a to infinity, function value is 0, therefore integral becomes 0. So this is equal to root 2 by pi. Now what is sin a cos, sorry, sin a sin b, or 2 sin a sin b? Anybody? Is it
Sin A
oh,
plus B plus sin A minus B.
sin a plus b plus sin a minus b ano, or cos a minus b minus
Cos
cos
A
a,
minus B minus cos A
Cos
plus
A
B.
minus B minus cos A plus.
cos a minus b minus cos a plus b. So this is equal to 1 by 2 times. So instead of a here it is x, and b instead of b it is omega x. So I can write this as integral 0 to a 1 by 2 I am taking outside. So cos of x minus omega x minus cos of a plus b. So x plus omega x dx. So now I will simplify this. 2 by 1 by 2 integral 0 to a. I can take x outside. So cos 1 minus omega x minus cos 1 plus omega x dx. Now I can integrate this. So this is I can cancel it out. So I will get 1 by root 2 pi. Root 2 and 2 get cancelled. You will get root 2 in the denominator. And I am integrating this. So cos 1 minus omega x integral is sin 1 minus omega x divided by 1 minus omega minus cos 1 plus omega x, okay, say 1 plus omega x divided by 1 plus omega 0 to a. So this is 1 by root 2 pi. I am applying the limit. I will get sin 1 minus omega a divided by 1 minus omega minus sin 1 plus omega a divided by 1 plus omega. If I put the limit, lower limit 0, this becomes 0, sin 0 0 minus 0. So the answer is fs of omega is equal to 1 by root 2 pi sin 1 minus omega a divided by 1 minus omega minus sin 1 plus omega a divided by 1 plus omega. So this is the answer. Now I will do a problem which is somewhat different approach, because so let me discuss this problem. So here third problem, find the Fourier cosine transform of Fourier cosine transform of uh, e raised to minus ax square when a greater than 0. So the one of the problem here is, here it is e raised to minus ax square. And we know that e raised to minus ax square dx, you cannot integrate. It's very difficult to integrate this function. Okay. So, we will use some techniques to do this problem. So listen carefully. So first I will write the formula. Fc of omega is equal to root 2 by pi integral 0 to infinity f of x cos omega x d omega. Sorry, dx. So this is equal to root 2 by pi integral 0 to infinity e raised to minus ax square cos omega x dx. So this integral we cannot. So in order to find fc of omega, you have to find this integral. But this integral is very difficult to. So what we will do is, listen carefully. In this case, if we cannot integrate this, and what we will do is, we will differentiate. I'm calling this equation number 1. Differentiate equation number 1 with respect to omega. So why we are differentiating with respect to omega? If I am differentiating with respect to omega, I will get here omega x into some sin omega x. Here only omega term is there. So if I differentiate omega, then I will get x sin omega x. And here e raised to minus ax square. So x into e raised to minus ax square will come. So now we will differentiate with this with respect to omega. So you will get dfc of omega divided by d omega is equal to root 2 by pi integral 0 to infinity e raised to minus ax square. What is the derivative of cos omega x? Derivative of cos omega x is minus x sin omega x, right? Okay. So this is equal to root 2 by pi into. Now what I will do is integral 0 to infinity. The problem here is while doing this integration is this part. So what I will do is I will take sin omega x. I can write this into x into e raised to minus ax square dx. Okay. Listen carefully. So just I am rewriting this or rearranging the terms. Okay. So I am first I write sin omega x into here. So now 2 by pi. Okay. So we know that what is derivative of d by dx of e raised to minus ax square? Anybody? This is actually e raised to minus ax square. Am I audible? Into Am I audible?
Yes, sir.
So, what is this derivative? So you just go through this. E raised to minus ax square into minus 2ax, right? So it's in place. Okay. So what will be the integral of e raised to minus ax square into minus 2ax? This will be e raised to minus ax square. So what I will do is I am multiplying here it with so here there is minus sign, right? I am multiplying here with 1 by 2a and integral 0 to infinity sin omega x into minus 2ax e raised to minus ax square dx. So this is equal to root 2 by pi into 1 by 2a. Okay. Now I am integrating this into integral of this. So that is sin omega x, this part, into integral of this is actually e raised to minus ax square. Integral of this. So that is e raised to minus ax square. I am giving the limit 0 to infinity minus integral 0 to infinity. Derivative of sin omega x is omega cos omega x into integral of this, that is e raised to minus ax square d. Now if I put the limit, which implies dfc of omega divided by d omega is equal to root 2 by pi into 1 by 2a. If I put the limit e raised infinity here, e raised to minus a into infinity. That means e raised to infinity, you will minus infinity, you will get minus 0. And if I put a limit as 0, sin 0 is 0. So this quantity becomes 0 minus integral 0 to infinity. I can take omega outside and I will rewrite it as e raised to minus ax square cos omega x dx. So this implies dfc of omega divided by d omega is equal to root 2 by pi into 1 by 2a. This becomes 0 minus omega. This part, this integral is actually fc of omega, right? Integral 0 to infinity e raised to minus. So I can write it as fc of omega. So what I got is dfc of omega divided by d omega is equal to root 2 by, okay, sorry, I can write here, root 2 by pi integral 0 to infinity, okay, root 2 by pi integral 0 to infinity e raised to minus ax square cos omega x dx is equal to fc of omega. So I can write, so this is not here, I can write minus omega by 2a fc of omega. So I got a differential equation. Now our aim is I have to find out fc of omega. So for that I will do few calculations in place. So this is a differential equation, first order ODE. So I can take similar terms together. So 1 by fc of omega dfc of omega is equal to minus omega by 2a d omega. So now this is in variable separable form. Integrating on both sides, I will get 1 by fc. This is log fc of omega is equal to minus 1 by 2a is a constant. Omega d omega, integral omega d omega is omega square by 2, omega square by 2 plus a constant. I am taking constant as log capital A. So this is equal to, if I am taking exponential on both sides, you will get fc of omega is equal to a into e raised to log a means, or I will write e raised to minus, I am taking exponential on both sides, 2a into 2 4a omega square in plus log a. So this is actually equal to a into e raised to minus omega square divided by 4a. Now it implies fc of omega is equal to a into e raised to minus omega square by 4a. Now there is a problem. So here we don't know what is a. If I know a, then we got fc of omega. So in order to find out a, actually we have fc of omega is equal to integral root 2 by pi integral 0 to infinity e raised to minus ax square cos omega x dx. Now what is at omega is equal to 0, then fc of 0 is equal to root 2 by pi integral 0 to infinity e raised to minus x square dx. Cos omega, cos 0 is 1. Okay. So now I will find the value. So now if I put x equal to or omega equal to 0 in this equation number 2, we get fc of 0 is equal to a. So a equal to fc of 0, and also we know that fc of 0 is this root 2 by pi integral 0 to infinity e raised to minus x square dx. So now you have to find out this integral. So before going to that, I will define what is gamma integral. So there is a special type of integral called gamma integral. This gamma integral is actually uh, gamma uh, gamma n is equal to actually integral 0 to infinity e raised to minus x power n minus 1 dx. So the e integral value എന്താണ് gamma n is equal to e raised to integral 0 to infinity e raised to minus x power n minus 1 dx. Also gamma 1 by 2 is equal to root pi, and also gamma 1 by 2 is root pi. So note this. So now we will convert this integral into gamma integral. So therefore root 2 by pi integral 0 to infinity e raised to minus x square dx, and put ax square is equal to t. Then 2ax dx is equal to dt, which implies dx is equal to dt divided by 2ax. That is equal to dx is equal to dt divided by 2 into what is x? X is so from here x is equal to t by root t by a. So 2ax is 2 into ax is root a root t. So I can write this as 2 by in, and when t goes to infinity 0, x goes to 0, t goes to 0, and x goes to infinity, t goes to infinity. So e raised to minus t into dx dt by 2 root a root t. So this is root 2 by pi 0 to infinity e raised to minus t. I can put 1 by root 2 root a outside, and this is t raised to minus 1 by 2. So t raised to minus 1 by 2 is, you can written as 1 by 2 minus 1 dt. So this answer is root 2 by pi into 1 by 2 root a. So this is actually gamma 1 by 2. Gamma 1 by 2. So this is equal to, I will get cancel. Okay. So 1 by root 2 a pi. Gamma 1 by 2 is pi. Root pi. Gamma 1 by 2 is root pi. So now what we will do is, so a is equal to root pi and root pi get cancelled, 1 by 2, which implies A is equal to 1 by root 2y. A equal to 1 by 2 root 2y. Now, what is so hence our solution is fc of omega is equal to, so the final answer is 1 by 2 root a, 1 by 2 root a, 1 by 2 root a e raised to minus omega square by 4a. So this is the answer. So in order to do this problem, we have to find integral inside, derivative inside integral. So I will give you similar problems, and okay. So I will give you an homework, like one problem. Find find the Fourier transform of Fourier Sine transform of e raised to minus ax divided by x. So for this problem also you have to take the derivatives. Okay. So try to do this problem. I think my
Sir, previous question ఒన్నూడ explain చేయమా?